Hi, everybody, and welcome to Echo Live. My name is Anna, and of course, I'm coming to you from the Michigan Science Center's Echo Distance Learning Studio. Today, we are doing a super fun experiment, which is an experiment that you can really easily do at home. And then I have a couple challenges for you, which I'm hoping you might be willing to play along with. Now, today, in honor of all the rainfall we've been getting here in our area, we are going to talk a little bit about water and what makes water such a unique molecule. The challenge that we're going to propose in this session is how many drops of water can we fit on various US coins? So I have 4 different US coins down here on our tray. I have a penny, aka a 1 cent US coin. I have a nickel worth 5 cents, a dime worth 10 cents, and a quarter worth 25 cents. Now, we said that the challenge is going to be how many drops of water can we fit on the surface of each of these coins. Today, we'll be mainly focusing right here on our good friend, the penny. Our penny is our 1 cent coin, generally this kind of coppery color. So you can very easily recreate this at home. All you'll need is a coin, a relatively flat surface. Flat surface is very important for the purpose of this experiment. And the other thing that you're going to need is a cup of water with something like a tiny dropper. So I have a pipette here, but you could use a turkey baster or an eyedropper or anything kind of similar, which is going to allow you to put 1 drop of water on the penny at a time. Now, a steady hand is also going to be very important for this experiment because, of course, we want to keep as much water on the surface of the penny while we are counting those drops as possible. So it's going to be important that for this experiment, we don't bump or shake the table. So do this in a place that you've got lots and lots of space, and maybe an extra set of hands to help would be great as well. If you have a guess about how many drops you think I might be able to fit on the surface of our penny here, no tricks about it, just a regular US penny, you can go ahead and tell me in the chat, how many drops do you think will fit? And with that, we're just gonna go ahead and get started. So draw up some water into my pipette, and then I'm just going to carefully add those drops 1 at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, my 20th drop pretty much brings us to the edge of my coin in all directions. So let's see, if we keep adding water, how many more drops do you think I could possibly fit on there? I guess we're about to find out. So remember, we are at 20 drops. So adding in number 21, 22, 23, 24, 25. Now, what's interesting is even though the water had made it all the way to the edge of our penny, as we're continuing to add drops, the water is not spilling over. We said that the focus of this, part of the trick behind this experiment, is some of those unique properties of water. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Oh, just shy of 40 drops. The 39th drop of water that I added to our penny caused that water to come spilling over the edge. Now, we were able to fit way more water than just fit flat on the surface of the penny. And that has a lot to do with those unique properties of water molecules. Water, like we've talked about many times here on Echo Live, is a polar molecule, meaning that it has a positive and a negative end of every single molecule of H2O, what we know as water. The negative side is where we see that big old oxygen atom, And the positive end of a water molecule is on the end where we have two of those teeny tiny hydrogen atoms attached. Water has a very unique ability to stick to itself like a magnet because of its polar structure. I'm sure you've played with a magnet at home, and we might know that a north end of a magnet and a south pole of a magnet will like to stick together, whereas two north ends will repel and two south ends will repel. But magnets work a lot like polar molecules. So when water gets near other molecules of water, it arranges itself in this very unique structure where oxygen is always pointed towards hydrogen and hydrogen is always pointed towards oxygen. And that magnetic structure, this process that we call cohesion, or when molecules like to stick to other like molecules, is what allows us to put so many drops on the surface of a penny. Now, we have a various amount of coins here, and our coins are all different sizes. We can compare them by surface area. So here is all of the dimensions and weights of the various US coins that have been in circulation at some point in time, going from the dime, which is the smallest of the US currency coins, all the way up to the $50, which is the largest of the US coins. Now, our penny is about 0.75 or 3/4 of an inch across. We can use that dimension in order to calculate surface area of a penny, and we can compare that to something like a quarter, which is the largest coin that I have down here on the tray. Now, between a penny and a quarter, we say there's about a 25% increase in surface area or length. So about 25% larger our quarter is than our penny. Now, I challenge you to think about how that might affect how many drops will fit on the surface of a quarter. But for today, we're not going to count them because I'd love for you to try this experiment at home. If you're interested in taking it further, I'd challenge you to figure out, is the number of drops that fit on the surface of each of these coins, is it related to surface area or is it not? Do you think we'll fit 25% more drops on the quarter? Or do you think it would be more? Or maybe it's less? Tell me what you think in the chat. If you try this at home, tell me how many drops fit on the coins that you try. And we'll be posting our answer to how many drops fit on the surface of our other coins in just a little while here today. Now, of course, thank you everyone for joining us for another episode of Echo Live. We will be back here next Wednesday at 2:30 with another exciting virtual experience. Of course, continue tuning in for the rest of the year. These programs are brought to you by Ford and Denso, who are continuing to sponsor Echo Live, and we'll keep bringing you experiments and demonstrations that you can watch from home throughout the entire summer and the rest of the year. So bye, everyone.